So they give you a function, and then we have x squared, x, and constant. Does this graph cut the x-axis? That means they ask you, is this graph totally above the ground, or this graph touch x-axis like this? So the key point is we consider when y is equal to 0. So we consider when y equal to 0. Then the function will be 2x squared minus 4kx and then plus 3k squared plus 5. We want to know, is there any real solution to fulfill this requirement. So basically we are testing delta equal to something. Is that larger than 0, smaller than 0, or equal to 0? Consider, because we are not solving the same equation anymore, so we consider delta is equal to b squared minus 4ac. b here is negative 4k. A is 2. C is the constant without any x, so we are talking about two terms together. 3k squared plus 5. If we extract common factor, it's easier for us to find out k squared and then plus 5. So k squared must be positive. Positive plus positive. So k squared plus 5 itself is positive. Time negative 8. So it must be smaller than 0. I repeat, because k squared is positive. So it must be some negative 8 times positive value. That's why the outcome must be negative value. Even though we don't know what is the value of k, is not fixed. But no matter what is k, the delta will remain less than 0. So we have no real root, which means no intersection. So the answer is the graph do not cut x-axis. Since we don't find any x can fulfill y equal to 0 this requirement, no matter what is the value of k. Or in part A, you may try to use competing square to get the vertex and then compare with our ground 0. See whether is there any x-intercept. So in part B, we are going to use competing square now. Don't forget the procedure. I hate 2x squared. I just want x squared. So I extract 2 for the first two terms. And then I want to put all x in one single square bracket. So I need to find out what is missing. By the identity a squared plus 2ab plus b squared equal to a plus b bracket square. I need to identify what is b. Therefore, we have something square minus 2 times something something. One item is x, and then what inside to give us back this one. Then what is missing should be k. So what is not enough is we need k squared. At the same time, I can't change the value, so I minus k squared immediately. I just create this item, what we want, from 0. And then outside the bracket, just copy, nothing to do. So now we have separate our target 3 terms and the last term. When you remove the bracket, don't forget negative k squared need to times 2. And this become a complete square. We successfully put all the variables, that means x inside a complete square. So this is the vertex form, and it gives us the vertex directly. When the bracket square equal to 0, this will become minimum. In this case, it's because the graph is open upward. So the vertex is k. When x equal to k, the square becomes 0, and then the outcome is k squared plus 5. The height is k squared plus 5. They say that S is some moving point on the original graph, and then T is some point in the graph after transformation. After that, they say that when S and T closest to each other, then their circumcenter something like that. So it's too complicated, and we need to understand the situation. So we need the original function, and also we need to know the graph after transformation. How does it look like? We know the original graph y equal to fx is like this. It's opening upward. Do not touch the x-axis. But are we not confirmed is that in right hand side or left hand side compared with y-axis? But just simply write in this way. We also know that there is a point which is the vertex. The x-coordinate is k. The y-coordinate is k squared plus 5. That's the vertex. Now we try to focus on another function. Y is equal to 2 minus fx. So fx is transformed to negative fx. And then plus 2, we get negative fx plus 2. It's the final function. So we analyze what is the effect one by one. Originally, it is opening upward. After we multiply negative, then it's refracted along x-axis, become opening downward. And then plus 2, that means every point we shift up by 2. That's how we get the graph. So after the first change, it will reflect along y-axis, which means that the new height of the vertex is negative k squared bracket k squared plus 5. And then in the second change, every point plus 2, so it shifts up. And the new vertex is negative bracket k squared plus 5 and then plus 2. We get the vertex, which is k, and then negative k squared minus 3. That means I expand it and then combine like terms. Now it's time to look for S and T. Please ignore the red line because we are just talking about the initial line and also the final line. S is any point on this curve. T is any point on the blue curve here. When they are nearest to each other, so obviously we are talking about their vertex. S is the vertex of original curve, and T is the vertex of the final curve. We can get this conclusion is because the curve did not shift left or right. That's why we know that only the vertical line, then we will find the closest point together. And then they say that we are concerning about a triangle OST and its circumcenter. O here, and then we have OST. That means this triangle OST. And the word circumcenter is talking about a triangle and then a circle pass through 3 vertex of the triangle. And one of the divided property is the perpendicular bisector of the chord. That means every edges will intercept at that point. So to get the circumcenter, our target is to get the perpendicular bisector of each side. OS and OT is not that convenient. ST is really convenient. It's because this is a vertical line. So its horizontal line is like this. Perpendicular bisector of this line is a horizontal line. And then circumcenter are somewhere on this line. They ask you, is that line on x-axis? Of course, our answer is no. Because it should lie on this horizontal line, which is not the x-axis. They never cross each other. So, to be more precise, our target is to claim the circumcenter line on the green line. We are going to find the height of the green line and then say that it's not x-axis. we say our finding is S is the vertex. And also, we say our finding T is the vertex of the final line. And then after that, we have to say that the circumcenter lie on the line. Y equal to the average of k squared plus 5 and also negative k squared plus 3. The midpoint between these 2 points, so the height plus this height divided by 2. We get 1, y equal to 1, which are talking about the green line here, y equal to 1, which never cross x-axis. So that's why the claim is wrong, incorrect.